There's this one scientific theory that's been keeping me up at night. And no, it is not the heat death of the universe or the fact that we might all be living in a computer simulation. It's the idea that there's another universe right alongside ours where time runs backwards. That's right. The very moments you're experiencing right now are being lived in reverse by some other version of you in some other universe. You just don't know it. It sounds like the plot of an action movie or maybe a bad acid trip. But this so-called twin universe paradox is actually a consequence of Einstein's theories of special and general relativity. And while the math is admittedly a little complicated, the basic concept isn't hard to grasp. So here's how it works. You may have noticed that time seems to pass differently depending on how fast you're moving relative to someone else. Say you're standing still and your buddy zooms by you in a rocket ship at half the speed of light. When he returns from his trip, having traveled to Alpha Centauri and back, he'll be younger than you. This phenomenon is known as time dilation, and it happens because the faster you move through space, the slower you move through time. From your perspective, your friend left and then came back a few years later looking younger. But from his perspective, he stayed still while you moved really fast away from him and then came back to him a few years younger. But what if you were the one who got in the spaceship and traveled at half the speed of light? Well, when you returned home after visiting Alpha Centauri, you would also be younger than your friend who stayed on Earth. In other words, time would have passed slower for you than for him, but this raises a bit of a paradox. If you were on the spaceship and time passed more slowly for you, wouldn't that mean that your past was actually their future and vice versa? We're gonna unpack that question and others in this video. So stick around to the end to find out what the heck is going on. To better understand this backwards universe thing, let's get back to basics. There are two fundamental concepts in physics, space, and time. Put together, they form a four-dimensional continuum called spacetime. Now, according to Einstein's theories of special and general relativity, space and time intertwined in this way are relative. What appears to be a second passing could actually be a meter or a foot or anything really, as long as both you and someone else aren't moving relative to each other. That means there's no such thing as absolute time. Time is always measured in relation to something else. In order to measure time, you need a frame of reference, which brings us back to that friend of yours who just came back from a trip to Alpha Centauri. If you want to know how much time passed while he was gone, you need to compare it to the amount of time that passed for you. In this case, your frame of reference, because you're not moving relative to each other, it's easy to compare time. If you were both on Earth, you could just look at your respective clocks. But if you were both traveling in spaceships moving relative to each other, it'd be harder to compare time because you're no longer in the same frame of reference. If you were on the spaceship with your friend, the only way you could measure time during your journey would be by comparing it to some distant star. Let's call it Star A while you're traveling. You could look up and see Star A moving through space just like you are. But since it's so far away, it appears to be almost stationary. So, from your point of view, if you traveled for 1 year to Alpha Centauri and back, Star A would appear to move a tiny bit to the right, but only by a very small amount. Meanwhile, your friend who stayed on Earth would see Star A move much more to the right because they aren't moving relative to it. They're staying still on Earth, so when your friend looked up at Star A, they would see that it had moved much farther to the right than you saw during the same amount of time. This means from your friend's perspective, much more time had passed than it did for you. Now, you might be thinking, what does this have to do with a backwards universe? Well, here's where things get weird. Imagine for a moment that you and your friend weren't measuring time on Earth or even relative to a star, but rather relative to each other. This is a frame of reference in which time would appear to pass normally until you reach the speed of light, at which point time would completely stop. This means that if you and your friend were in a spaceship traveling at half the speed of light, time between the two of you would continue to pass normally, say 1 minute followed by another and another. But if you stopped moving relative to your friend, time for you would completely stop and you'd remain in whatever minute you happen to be in. Meanwhile, time for your friend would continue to pass normally. From their point of view, you would remain stuck in the past while they continued to move forward. And if you were the one traveling at half the speed of light, time would pass normally for you. But if you stopped moving relative to your friend, you'd be catapulted into their future. So basically, if you were traveling in a spaceship with your friend at half the speed of light and you stopped relative to them, you'd be thrust into their future. But if they stopped relative to you, they'd be thrust into your past. In other words, the two of you would cease to be in sync with each other as far as time is concerned. And the only way for you to get back in sync would be to keep moving relative to each other at half the speed of light. Now, let's imagine that instead of you and your friend, we're talking about the entire universe and its antimatter counterpart. Scientists theorize that there is a universe composed entirely of antimatter, meaning that every particle of matter has an anti-counterpart with the opposite electric charge. To make things easier, let's assume that our universe has no antimatter in it whatsoever. It's pure matter. If our universe stopped moving relative to its anti-counterpart, everything in our universe would fly backwards in time. And if the anti-universe stopped moving relative to us, everything in the anti-universe would fly forwards in time, just like our universe. In both cases, the universes would appear to be moving in opposite directions. Some physicists think that the only way for these universes to stay in sync with each other is to keep moving relative to each other at the speed of light, just like you and your friend in the spaceship. That means that there could be two universes, one made of only matter and one made of only antimatter, moving alongside each other with everything happening in reverse in the antimatter universe. When you look at an object in the antimatter universe, you see an exact replica of it in our own. But because everything in the antimatter universe is moving backwards in time, it looks like it's moving in reverse. An hour after you eat a sandwich in our universe, you see yourself in the antimatter universe eating the same sandwich, but you're 10 years younger. At first glance, this seems to violate the conservation of entropy, which states that disorder always wins in the end. If the antimatter universe really is our past, then shouldn't it be more disordered than our present? But here's where things get weird again. In the antimatter universe, the 10-year younger version of you eating that sandwich is the most disordered state possible, whereas your current state is highly ordered in comparison. Remember, entropy wins in the end, but remember also that time is relative and dependent on your frame of reference. If you were in a spaceship traveling towards the past younger version of yourself, you would see a version of you that's older and more disordered. So as far as entropy is concerned, everything's in balance. And that is why scientists think these two universes could exist side by side with everything happening in reverse in the antimatter one. Our past is their future. Their past is our future. In other words, we're all living in a giant time-reversed Easter egg, but why haven't we seen it yet? Well, the antimatter universe, if it exists, is probably cloaked in a bubble of negative energy. That bubble prevents us from seeing what's inside because normal matter and antimatter annihilate each other on contact, releasing massive amounts of energy. However, scientists think that a baby universe made of antimatter could have formed in a small region of space where there was already a lot of matter. That's because matter and antimatter can coexist as long as they don't touch. And the more matter there was to begin with, the bigger the bubble of negative energy surrounding the baby antimatter universe would be. If that's true, there could be many universes around us, each made of only antimatter and each existing in its own bubble of negative energy. Because of the conservation of entropy, each bubble would be more disordered than the last. And the further away a bubble is, the more likely it is to have evolved in a different direction from our own. Maybe in one bubble, life evolves in a completely different way. Dinosaurs never go extinct, or they do, but they evolve into tiny versions of themselves that live in trees. Or maybe life doesn't evolve at all and the planet becomes a barren wasteland. Who knows? Anything's possible. All of this is purely hypothetical, of course, but it makes you wonder if we really are living in a giant Easter egg of our own past. Maybe someday we'll have the technology to find it.